Michelle Sterling for Friends of Science Society. I'm here in Porto, Portugal for the Basic Climate Science Conference that was just held at the University of Porto.
Is there a correlation between temperature of the Earth and CO2 emissions? In black you see the data by the Hadley Center in Britain, in Great Britain, and in red the satellite measurements at the University of Alabama at Huntsville. So is there a correlation? I will say no. Why? Because you see, when CO2 started accelerating between 1945 and 1975, temperature was decreasing. Definitely there is no correlation. Okay, after that there have been an increase of temperature, but no more than between 1910 and 1948. No correlation. Of course, the CO2 emissions nowadays are 6 times more than it was between the period from 1910 and 1945. Conversely, we see a good fit with a 60-year cycle plus a straight line. But this straight line doesn't fit the CO2 emissions due to this change of slope you see in 1945. This fit with a 60-year cycle gives much better agreement with data than this is a picture which is taken from IPCC AR5 report. You see during the first increase between 1910 and 1945, the models, same IP5, doesn't see the increase that has been observed. And now there is the problem of this century. You see again there is a disagreement. Let's have a zoom on our century. This is a picture taken from the IPCC AR5. You see the measurements and you see what says the models. Not only the models doesn't fit the experiment, but they don't fit each other. They disagree with each other, the models, even with the same color, which is the same scenario. Another picture which is also inside the IPCC AR5 report. It's another way to show the same thing. In red, you have the observation in the period indicated. And in black, you see the CMIP5 models. They run too hot, that's clear. All of them. So the alarmism is not validated. This 60-year cycle is not only seen in temperature measurements, but also in other climate sentinels. For example, the sea level rise of oceans, they also show this. Of course, there is much uncertainty on the data, but anyway, computer find a sine function that is in agreement with the data. And also in between, you see the array of Arctic ice. When the temperature was low there is a maximum of Arctic ice. And then when the temperature was higher, there was a low of Arctic ice and so on. And we see the same now. This 60-year cycle is reported in many peer-reviewed papers, including, I mentioned that of Nicolas Scafetta, who is in the audience. And there is a possible explanation by a tide effect. A tide effect on big planets of the solar system upon the sun, which is easily deformable because it is gas. Another possibility is the correlation of this cycle with what is called the Atlantic multidecadal oscillation. Here is a plot of climate sensitivity published in peer-reviewed papers. Some of people in the audience are among the authors of some data. Is it clearly the alternative or postmodern definition of consensus? Is it? Well, I recall the definition of climate sensitivity. It is Earth, warming of the Earth in case of CO2 doubling. There are two definitions: transient climate response, TCR, and equilibrium climate sensitivity. Transient is at the time of doubling of CO2, while equilibrium assumes several more hundred centuries to arrive to this equilibrium. But anyway, in both cases, if just a linear regression of the data point shows there is a cooling. Why? Probably because a number of authors have just noticed that in the low troposphere temperatures since 2 decades doesn't change except fluctuations. At 10 kilometers, at the altitude at 10 kilometers, temperature has not changed in 4 decades. And we will see in a few minutes that in the low stratosphere, the temperature has not changed since a quarter of a century. So that's why, that's a possibility anyway. What is the increase, not of the emissions, but of the increase of CO2 in the atmosphere? It has been increased till the beginning of this century. Since this beginning, it is almost a constant 2 ppm per year. 2 ppm per year. That will mean that till 2068, in 50 years, there will be, if we extrapolate, 100 ppm more CO2 in the atmosphere. Okay? Alors, why 2068? It's because according to a paper by Olila, we use the data of BP, British Petroleum, the known reserves of gas and oil known today will be finished in 50 years. Of course, for coal, it's much more time. But known reserve, of course, we can discover more. But anyway, that allowed to make some calculations. What does CO2? This is the infrared spectrum of the atmosphere. We see, essentially, the absorption by water vapor. Essentially by water vapor. Only 2 peaks, or absorption, since it is the transmission, 2 peaks corresponds to CO2. It's very easy to understand. You see that young girl, if she kisses alternatively each boy, that's one vibrational mode. Or, this is not the dominant one because the other one, she's just hesitating like that. She's hesitating, like a Chinese reading a book, like that. Okay. So, very easy. Both those absorption in the atmosphere absorb 100% of the radiation emitted by the Earth. 100%. We could say it is almost saturated. This is exactly what had published Rasul and Schneider. I said Schneider because after that he became a well-known alarmist, but at that time he was not. Why? Because Earth was cooling at that time. And he considered a climate sensitivity of 0.8 degrees. 0.8 degrees. And he explained that this is because the CO2 bonds saturates and the addition of more CO2 doesn't substantially increase the infrared opacity of the atmosphere. Well, I'll not detail the calculation because this is, one, it is very easy. We start from Stefan Boltzmann equation, make the derivative, and therefore arrive to a simple equation that allows to predict almost 0.2 degrees of AGV in 2068. Experimental verification. That's very important. In the low stratosphere, normally we would expect temperature change. There is no temperature change with two different satellite measurements since a quarter of a century. No temperature change. If we believe IPCC, you should have this temperature change. This is not observed. Why? The greenhouse effect, according to IPCC, is the definition is there. It is, they consider a lowering of emission by CO2 at high altitude due to an excess of CO2. Increased altitude means increase of temperature. Decrease of temperature with altitude. But what happens actually? This is infrared spectrum again, and this band at 15 microns. In the troposphere below, above the tropopause at 11 kilometers above. You see the absorption in both cases is always 100%. And above 11 kilometers, the temperature doesn't longer decrease, but stays and increase again. Increase of temperature means a cooling effect. Decrease of temperature means a warming effect. Okay. This is because simply the saturation which is observed in the low stratosphere does not longer is observed at high altitude because pressure is lower. And since pressure is lower, the dissipation of heat is by another mechanism, no longer collision between molecules at low altitude, it becomes emission, radiative effect at high altitude because much less collision, of course, at high altitude due to the low pressure. In addition, but I will not discuss that, again, one of the authors of this work is my chairman, so Nino Wells. That's very interesting. Is CO2 so dangerous that it warms the Earth before it has been emitted? That's what says these measurements. Of course, normally the consequence follows the cause. It's reversed. Well, I will not discuss because I will need time to discuss that, but that means, okay, that means that the ocean release CO2 because there are 60 more CO2 in the ocean than at the atmosphere, and that might be the explanation. But if that is true, that will mean that, well, I skip that one, that, well, maybe not. Well, this picture has already been shown today. There is no correlation again. Why? If we admit there is a climate sensitivity of 0.6 degrees, of course, you will not observe it, because either a doubling of CO2 or dividing by 2 will not change anything within the temperature range. This is also true for, now I just want to use the last minute to insist on Earth greening. This is observed by satellite, 18 million square kilometers. More interesting is the increase of the seasonal oscillation with time. Now, in La Jolla, you see the increase of amplitude of this oscillation is larger than it has been. It increased more rapidly than CO2 itself. This is the way to arrive to this conclusion. I'll let you read. Thank you.
Thank you very much.